Hello students, in today's session we are going to learn Bayes theorem, which is very important because one question comes from this exercise 13.3. Question is very lengthy, but solution is not lengthy, directly based on formula. So some terms related to Bayes theorem. First term is partition of a sample space. So what is the partition of a sample space? Suppose this rectangle represents the set S sample space. You divide this, suppose this is one part E1 and this is another part E2 and this is E3 and E4. So I have divided whole sample space into 4 parts and each part will be subset of sample space. So E1, E2, E3 and E4 are events of the events with respect to this sample space. So these events, set of events you can say is called partition of the sample space. So if you observe here, two events have no common element, so mutually disjoints, and if you unite these 4 events you will get whole sample space. So this is the condition when set of events will be partition of a sample space. So let us define this definition of partition of sample space. A set of events like E1, E2 and En is said to be partition of a sample space S if first condition is union of this all union E2 union union En is equal to S. Second is two events must be mutually disjoint. It means any two events no common elements. So EI intersection EJ is equal to 5, where I is not equal to J and IJ equal to 1, 2 and so on, but both are not equal. E1, E2 are disjoint, E2, E3 are disjoint. So two events, usually two events are disjoint. Third condition is probability of EI should be positive for all I is equal to 1, 2 and so on. So this is the partition of a sample space. Now second term or second formula we can say total probability theorem. These are the part of Bayes theorem. Total probability theorem. Let E1, E2 and En set this is a partition of the sample space partition of S and A be any event. A be any event. Then according to total probability theorem, then probability of A, here sample space has been divided into n events. So probability of A will be probability of E1 into probability of A E1 plus probability of E2 into probability of A E2 up to n terms plus probability of En into probability of A. In short, we can write this in summation form. Probability of E J into probability of A E J, where J value from 1 to n. This is called theorem of total probability or total probability theorem. Which type of questions are solved in Bayes theorem? Suppose there are two bags, bag 1 and bag 2, and bag 1 contains, suppose, red ball, 4 red ball and 6 black ball, and bag 2 contains 3 red ball and 7 black balls. There are two bags. Bag 1 contains 4 red ball and 6 black balls. Bag 2 contains 3 red ball and 7 black balls. Now one ball is drawn from this any one bag, and it is known that the drawn ball is red. What is the probability that drawn ball is from bag 2? So here sample space is divided into two parts. We can select either bag 1 or bag 2. So we know the drawn ball is red. In that situation, we have to find probability of the bag in which ball is drawn. So this type of question we solve in Bayes theorem with the help of Bayes theorem. So Bayes theorem is very useful to solving this type of questions. So there are many questions in your textbook. So this is total probability theorem. Now Bayes theorem. So definition. Bayes theorem condition is same. Suppose these are the partition of the sample space and A be any event. Then probability of E I of the A. Suppose drawn ball is red, and we have to find what is the probability that drawn ball is in second ball. Here E2 will come. So for this, probability of E I into probability of A E I divided by this total summation probability of E J into probability of A E J. Here also J vary from 1 to n. So this formula is called Bayes theorem. Condition is same. Here E1, E2, E3 are the partition of a sample space and A be any event. question from the exercise 13.3. Two questions I have written here. Question number 1 is based on total probability theorem and second is based on Bayes theorem. So let us solve question number 1. An urn contains 5 red balls and 5 black balls. So number of red ball is 5 and number of black ball is 5. A ball is drawn at random. Its color is noted and returned to the urn. Moreover, 2 additional balls of the color drawn are put in the urn. And then a ball is drawn at random. What is the probability that second ball is red? So we have to find the probability that the second drawn ball is red. But second drawing depends on first drawing. If first drawn is red, then 2 more red color balls will be put in the urn. So number of red ball will increase here. If first drawn ball is black, then number of black ball will increase here. So sample space will be divided into 2 parts. First, when first drawn ball is red, and second, the first drawn ball is black. So let us define event, that event E1. First drawn ball is red. Drawn ball is red. And E2, first drawn ball is black. So there are what is the probability of, here we have defined this also, A that means second drawn ball is red, which we have to find. Second drawn ball is red. So this we have to find here probability of A. But sample space is not unique. In both the situations we have to consider the sample space. So probability of, according to our formula, probability of A is equal to probability of E1 into probability of A of the E1 plus probability of E2 into probability of A E2. So probability of E1 first drawn ball is red. Number of red ball is here 5 by 10 is equal to 1 by 2. Probability of E2, that is first drawn ball is black, again 5 by 10, that is 1 by 2. Now probability of A of the E1. What does it mean? Probability of second drawn ball is red. It is given that first drawn ball is red. It means we have to put 2 more red balls. So number of red ball will be here 7. So number of favorable outcomes is 7 and total number of outcomes is here 12. So 7 by 12. Now probability of A E2. That means second drawn ball, probability of second drawn ball is red. It is given that first drawn ball is black. in that situation number of black ball will increase. So 7, and here number of red ball will remain same. So 5 by 12. Now we got all the value. Simply you put here 1 by 2 into here 7 by 12. 7 by 12 plus 1 by 2, and A into is 5 by 12. 5 by 12, 1 by 12, 1 by 2 is common. Then 7 by 12 plus 5 by 12. This is equal to 1 by 2. So this is the answer of this question. Solution is not difficult. Only you have to interpret the question. So question you read carefully and write down the mathematical part separately and apply the formula. Now second number, which is based on Bayes theorem. So question is, a bag contains 4 red balls and 4 black balls. So there are 2 bags, bag 1 and bag 2. Bag 1 contains red ball 4 and black ball 4. Another bag contains 2 red balls and 6 black balls. So red ball 2 and black ball 6. One of the 2 bags is selected at random and a ball is drawn which is found to be red. Okay. So we have choice here. We can select one bag from the given 2 bags. So suppose even is the event that bag 1 is selected. Bag 1 is selected. Selected E2. Bag 2 is selected. Is selected. Obviously, probability of even bag 1 is selected is 1 by 2. There are 2 bags. Probability of E2 1 by 2. So here A, another event, red, and a ball is drawn which is found to be red. Red ball is drawn. Red ball is drawn. Now we have to find probability from the first bag. That means probability E1 of the A. Conditional. What does it mean? Probability of E1. E1 means first bag is first bag. So ball is drawn from first bag. It is given that the ball is red. So according to our formula, probability of E1 into probability of A E1 divided by probability of E1 into probability of A1 plus probability of E2 into probability of A2. So this value we have to find here. E1, E2 we got. Now probability of A1. Probability of A1 means what is the probability that drawn ball is red when bag 1 is selected. So 4 by 8. This is 4 by 8, that is 1 by 2, and probability of A E2. That is the drawn ball is red when bag 2 is selected. So 2 by 8, that is 1 by 4. Now we got each value. So we can put here probability of E1 1 by 2, A E1 1 by 2 divided by 1 by 2, 1 by 2 plus 1 by 2 into probability of A into 1 by 4. So 1 by 2 is common, 1 by 2 you can cancel it, then 1 by 2 divided by then 1 by 2 plus 1 by 4, 3 by 4. 3 by 4 is equal to 1 by 2 into 4 by 3, that is 2 by 3. This is the answer. Okay, thank you.